Okay, let's start. I'm going to share my Adobe camera. Okay. Okay, start. Okay. So we are studying the chapter 6, distribution of the function of random variable. So u is a function of the random variable y, right? And we do have the density function for the y, and we want to find the density function for the u, right? That's what we are doing. So we have the three methods: the distribution function technique, transformation technique, and the moment generating function technique. Okay, so right now we are doing the first technique, the distribution function technique, and for the universe case. So what we do here is now we want to eventually find the density function of the transformed random variable u. So we are given the PDF of the random variable y, so we can find the CDF, cumulative distribution function, and we want to find the PDF of the u. So cumulative distribution function for the u, we first find this one, and once we find this one, then we can take the derivative and find the PDF, right? That's what we do. Now, last time we did a two example before. It is also in the. Now we want to do the example 6.1 here. So this is the book exercise here. Now let y be the random variable with a probability density function given by this one here. So y is the random variable here, and we have the density function given here. Right? Now we want to find the density function of this random variable y and random variable u, which is a function of y, right? So u1 is a function of y, random variable y, right? Now we want to find the density function of f. We want to find the density function of f u, and we will write the u to know that it is a density function for the random variable u, right? U. Now, first of all, find the cumulative distribution function for y, and let me put the y here so that it is for the random variable y, right? So this is equals to integration. Now the lower limit is 0 here, 0 to y, and density function is here. So let me put the ft dt, right? So this is equals to 0 to y to 1 minus y, 1 minus t, okay, 1 minus t dt. So this is equals to 2 y to t, another y, t minus t square over 2, right? Now this is equals to 2t minus t square divided to y. Now 2y minus y square, right? So that is the CDF for FYY, right? Therefore, FYY equals to 2y minus y square, and y lies between. Okay. Now we want to find the density for this u here. Then we have u1 equals to, let me put one u here, okay, 2y minus 1. Now first find the CDF of f2 and then we want to find the CDF of fu and u. So this is equals to, apply the formula here. This is the probability that random variable u is less than or equals to u. Right. Now this u equals to probability that, plug in this value here, right? This u here, 2y minus 1 is less than or equals to u. Right. Now solve for the y here. Probability y is less than or equal to u plus 1 over, right? Now this is the random variable y here, right? This is the random variable y. Random variable y, right? That is a random variable y. Now we can write this one equals to CDF function f u plus 1 over 2, and the random variable is now y. Now that is for the random variable y, right? Random variable y. Yeah. Now you see here this FYY. Now you already know what is the CDF cumulative distribution function for y. You see this one here, y, right? You see this one here, right? So you plug in the values here. So this is the input value, right? Input value, right? Right? So this is input value here. You plug in those values in here, right? So this is equals to 2y. So input is now this one here. 2. What is now input here? U plus 1, right? U plus 1 over 2. U plus 1 over 2. And minus y square. So in place of y square, you have to plug in this value here, right? U plus 1 over 2. Right? Now this is equals to, now if you, this one will cancel, so equal to u plus 1, and you have 4 here. This is equals to minus u plus 1 whole square divided by 2. Is that correct? Hmm? Oh, this is 4, right? Okay, this is okay. Now this is your 5. Now you want to find that this is a CDF, right? Now you want to find the probability density function, right? A probability density function. To do the probability density function, f u of random variable u. So you took the derivative of this one here, right? Derivative of f u u u, right? You take the derivative of this one, right? So this is equals to f. So you can write the notation f u. Okay. Yes. Now take the derivative of this one here. So this is equals to d over du. Take the derivative of u plus 1, right? Minus u plus 1 whole square over 4, right? So take the derivative here. So this is equals to, if you take the derivative, this is equals to 1, this will be 0, right? Plus 0, minus, you take the derivative of 1 over 4 will be here. So equals to 2 u plus 1, right? And then 1, right? Yeah, we're using the chain rule. Yes, using the chain rule. Right? So this is equals to, now this 2 cancel, so equals to 1 minus u plus 1 over 2, right? Yeah. So this is equals to 2 minus u minus 1 over 2. So equals to 1 minus u over 2. Right? Yes. Yeah. Which one? This one? This one? So you took the two factor here. 2 minus u minus, and this is negative, so this will be minus 1 here. Right? Now this is the density function we want here, right? Now we have to put the support here, right? So whenever y equals to 0, then u equals to 2y minus 1. So equals to 2, 0 minus 1. So equals to negative 1, right? Yeah. So whenever equals to 1, so equals to 2, 1 minus 1. So equals to 1, right? So that is the support here. So therefore, f u equals to 1 minus u 2, and u lies between now negative 1 and positive 1 and 0 elsewhere, right? And this is the answer. Yes. You get that one? You get this one? Okay. Now another question, continuation of this one, okay? Now we want to find the part B here, okay? Part B, expected value of u1 equals to 1. If you want to find the expected value of this u1, you find the density function for this u1, right? Now you want to find the expected value, right? If you want to find the expected value of u1, so expected value of u1, okay? So this is equals to u fu u du, right? That is a formula, right? Right? Yes, that is a formula. And now the support u of support has -1 to +1 here, right? Right? So you put the -1 to +1 here. Okay? -1 to +1. Okay. Now this is equals to integration -1 to +1 u, and fu is the same as you found before here. So it is the same in this one here. Okay. This. So 1 minus u divided by 2. So that is 1 minus u divided by 2. Right? Okay. So this is equals to 1 over 2. Now you can write this on -1 to 1. So u minus u square du. Right? Yes. So this is equals to 1 over 2. So u equals to, now if you do the integration, this is equals to u square over 2 minus u cube over 3. And you plug in into 1 to 1. Right? Yeah. Huh? What did you say, Amanda? U square. Now you see, this 1 over 2, I plug in this outside here, right? Now you distribute here, you multiply 1 u, and you multiply this negative u, this u square, right? Huh? This one? Why are we doing this one? Or you integrate this one? Integrate u square over 2. Integrate u square, then u cube over 3, right? Now you plug in those values here. So this is equals to 1 over 2. Now 1 over 2, 1 square, right? Minus 1 cube over 3 minus 1 over 2 -1 square over 2 minus -1 cube over 3. Right? Yes? So this is equals to 1 over 4 minus 1 over 6 and minus 1 over 4. This is negative, negative positive, and this is negative, so this is positive here. 1 over 6. Positive, negative. Cancel here, everything. Something is wrong, right? So this is positive, right? This is 0. It's not a 0. Where is wrong there? This is negative here. This is negative. This is positive, negative. So this is equals to -1 over 6 and -1 over 6. So equals to, this is equals to -2 over 6. So this is equal to -1 over 2. That is the penalty, right? So this is negative, right? So negative and negative, this is positive, right? Positive and negative, negative. Okay, so part B, this one here, right? Now, if you use the previous method, right here, using previous method, previous method. If you use the previous method, expected value of u1, so this is equals to expected value of, now u is now here 2y minus 1, right? Right? So equals to 2y minus 1, right? Now it is equals to 2 expected value of y minus 1, right? Yes. Now what you do here, you find the expected value of find expected value of y, right? Expected value of y. So to find that one, so it is equal to integration y f y dy, and y goes from 0 to 1, right? So this is equals to 0 to 1 y. Now f y dy is here, this one here, 2 1 minus y, right? 2 1 minus y. Okay, so this is equals to integration 0 to 1. So this is equals to 2 y minus 2 y square dy, right? So this is equals to 2 y square over 2 minus 2 y cube over 3 0 to 1, right? Now you plug in here, this cancel here. So this is equals to 1 minus 2 over 3. So this is equals to 3 minus 2 over 3. So this is equals to 1 over 3. Now this is the expected value of y, right? Therefore, expected value of y equals to 1 over 3. Right? Now use this one here. Expected value of u1 equals to 2 expected value of y, 1 over 3 minus 1, right? So this is equals to 2 minus 3 over 3. So this is equals to -1 over 3. You get this one? Yes. Yeah. Okay. So this one here. Now this one here. This is the exercise 6.3. It's from the book. Okay. Now, a supplier of kerosene has a weekly demand of Y, possessing the probability density function. Now, this is a probability density function here. It is a piecewise here, right? Piecewise here, right? Piecewise. So this probability density function, if you draw the probability density function, so it is for up to 1 and just say this is 1 and this is equals to 2. Okay. Now for 1, it is equals to Y. So this is equals to Y here, then it will go up to 1.5. 1.5. Those kind of density function, right? Yes, that density function. Now, with measurement in 100 of gallon, okay, gallon. The supplier profit, now the profit here, right? Profit is given by 10Y minus 4. Find the probability density function of you. You want to find the probability density function of the profit. Okay. Now first find the CDF of Y. Okay, CDF of Y. Now Fy equals to, now for this one here, you just integrate here, right? So equals to Y square over 2, right? Yes. And that is for Y lies between 0 and 1. Now you see here, for Y lies between 1 to 1.5. Fy equals to, now up to this point here, right? Up to this point here, you will have the, if you plug in 1 here, right? So it is equals to integration 0 to 1 Y dy plus integration 0 to Y 1 dy, right? Yes, you have to do the integration up to this point here and then do the integration for this one also. So this is equals to Y square over 2, 0 to 1 plus Y. 1 to Y. 1 to Y. So Y 1 to Y. Right? Did you get this one? You understand this one? It is not the same as you are doing before because it is a piecewise here. Now we are doing the CDF of this one here. So you have to integrate up to this part using this function here. Right? Now you want to do the integration in this part using the another function here, this one here. You get this one? Okay, so that's what it is, from 1 to Y. So this is equals to 1 square over 2 minus 0 plus Y minus 1. So this is equals to 1 over 2 plus Y minus 1. You see, this is equals to Y minus 1 over 2. So this is equals to Y minus 1 over 2 when Y lies between greater than 1 and less than equals to 1 and 1 elsewhere. Y greater than or equals to 1.5. right? Now you want to find the density function for u. Now find the CDF of u equals to ny minus 4. Okay. Now this is equals to f u u. So this is equals to probability u is less than or equals to u, right? U is less than or equals to u. So this equals to u. You plug in this u here, right? So probability ny minus 4 less than or equals to u, right? Now this is equals to probability ny is less than or equals to u minus 4, right? So this is equals to probability y is less than or equals to u minus 4 divided by 10, right? Yes, u minus 4 divided by 10. Now this is the definition for the random variable y, right? So random variable is y, random variable y, right? Yes. So this is equals to f y u minus 4 over 10, right? Then you plug in this value here, this value in here. So f u equals to, now for the y square, right? You see here. Then u minus 4 over 10 whole square, right? Then divided by 2 here, right? Y square over 2. So you plug in this value here and divide by 2, right? So this is equals to u minus 4. This is 10 square equals to 100, so equals to 200 here square. Right? So it is a little bit different than whichever you are doing straightforward, because it has a 2 pieces here, right? Yes. Now here you see here. So for this part now, plug in the u minus 4 over 10 minus 1 over 2, right? So this is equals to u minus 4 10. So this is equal to 5 5, so equals to -5, right? U plus 4. So this is -4. I have, it should be plus here, plus and plus. This is plus here. Yeah. So this is equals to divided by 10. So this is equals to u minus 1 over 10 and 1 here. This one? But this one is this one here. Yeah. -5. Now you have to take the factor 10 here, right? So you have to multiply by 5 and 5 here, right? Okay, now Now you have to take derivative of f u get f u. Take the derivative of the CDF to find the PDF, right? So f u. Now you take the derivative of this one here. So this will give you the d u plus 4 over 200 whole square by du, right? So this will give you the answer here. And for this one here, you take the du and u minus 1 over 100. This will give you the answer here, right? Yes. So if you take the derivative here, so this is equals to 1 over 200 to u plus 4 and then u plus 4 and then 1. And here you will have a 1 over 10 and 1. Right? So this is equals to, you cancel this one here, this is 100. So equals to u plus 4 over 100. And this is equals to 2. Right? Now you have to, therefore f u equals to u plus 4 over 100 and 1 over 10, right? 1 over 10. Now find the support. Find support, right? Now whenever y equals to 0, then u equals to 10y minus 4, right? So equals to 10, so y equals to 0 minus 4, so equals to -4. When y equals to 1, so 10, 1 minus 4, so this is equals to 6, right? So you will write here, u lies between -4 to 6, right? Now, whenever y equals to 1.5, so 10, 1.5 minus 4. So this is equals to 15 minus 4. So this is equals to 11, right? Right? So for this one here, u lies between 6 to 11. And this is the answer here. Do you understand this one? This is not the same problem as you are doing. Yeah, you understand? This is not the same problem as you are doing before. You can have a picture now. Okay? You get it? So you have the same similar problem in your assignment also. And the freedom. Okay? What is the time? 45? 12:45. Now, what is the part B here? Expected value of u. You want to find the part B, expected value of u here, right? Now, to find the expected value of u, now it is not the same as you are doing before. It is also because we have the it has a piecewise. Okay, so you have to do the piecewise here. So integration u du, sorry, fu du, right? And the support is from -4 to 11 here, right? Right? So -4 to 11, right? Yes. Now you have to do the piece, this piece and this piece separately. Right? You understand? one piece, because density function are different, right? Density function are different, right? Yes? See, Tiana, if you understand it. So you have to indicate this part and this part separately. Okay? So you have to do, this is equal to integration -4 to 6, right? -4 to 6 here. 6. And u, the density function is u plus 4/100 du. And for another part, integration 6 to 11 u 1/10. Do you get this part here? You understand? Huh? Okay. If you understand this one, then so this is equals to 1/100. So integration of -4 to 6 u square plus 4u du plus, now this is u, so 1/10 u square over 2, 6 to 4. Okay, 6 to 4. Now you just do the integration here, 1/100. So u cube over 3 plus 4 u square over 2. Right? Now you plug in -4 to 6 here, plus now 1/20. So this is equals to 4 square minus 6 to 11 here. It's not 11 here, right? So it is equals to 11 square. 11 square minus 6. Right? Right? So if you do that one, then you will get the answer. So this is equals to 67.21, so approximately equals to 5.53. Okay. You get this one? Huh? Okay, so I will stop here. So if you get this one here,